Good evening, everyone. Am I audible?
Good evening, ma'am.
Yes, you are.
Thank you. So, welcome to the first live session of Programming Concepts Using Java course. I'm Kubra, one of the course instructors of Java. Firstly, I would like to go through the syllabus of the course, uh, just for understanding what is there. Hope my screen is visible. Okay, thank you, Aryan.
Yeah, ma'am, it is.
So, the title of the course is Programming Concepts Using Java. So here we can say it's like we're going to learn programming concepts, and for illustration purpose we are using Java language. Okay. So in the very first week, we will understand what is programming, a normal introduction to programming, and then the different types, data types. We'll go through some of the concepts of memory management, stack, heap, etc. Then abstraction and modularity, and then we'll see object-oriented programming concepts, including classes and objects, and some of the OOPS concepts like dynamic dispatch, polymorphism, etc. And in week 2, we'll introduce directly the Java. Exact syntax of Java will be introduced in week 2. And one more thing I want to say is in week 1, you may see some of the Python code while explaining some of the concepts. Okay. Because you are not introduced to Java yet. So Python, as you already know, it is included here. So in week 2, introduction to Java, we'll start with printing hello world, then basic data types in Java, then control flow, for loop, and if blocks, all those while loop, everything will be discussed here. We'll also see how to define a class in Java and how to create objects. Then we'll go to input and output, how to take input from the user, how to print output to the console, all these things. So basically in week 2 you will learn most of the syntax that you want to use in this particular course. In week 3 again we'll come back to object oriented programming concepts in detailed manner. We'll start with inheritance. Okay, and inheritance we have subclasses, superclass, all those terms, and then we'll go into polymorphism and the concept of method overriding, overloading, all those things. And then class hierarchy. We'll see the class hierarchy in Java. And in week 4, again, another object-oriented programming concept, abstraction, will be dealt in detail. So we will introduce you to abstract classes, a special type of classes in abstract in Java. Then interfaces, again, it's a part of abstraction. You will also see private class. Then you will see controlled interaction with objects, little bit complex topics. Then callbacks, iterators. Iterators you may know from Python. And in week 5, we'll come to another topic, generics. So again, in generics, first we'll actually deal with polymorphism, one of the OOPS concepts, and generic programming, and then reflection, and we will deal mostly with generic concept in Java in detail in week 5. So in week 6, we'll come to collections in Java. So in Python, you might have already seen list, tuple, dictionaries, etc., right? So similar to that, in Java, we'll also have some of the collection to store multiple values into a single unit. So we'll see different types of collection, including uh, map. Map is similar to dictionary. Then in week 7, we'll see errors and exceptions. Errors and exceptions that usually occur in our program and how to deal with that using try catch block, etc. And then we'll also see packages, what is package, then assertion, something related to testing, logging, you may have seen some logs somewhere. So those things will be dealt in week 7. In week 8, we'll move on to some of the advanced concepts like cloning, how to clone an object, how to create a deep copy, type interface, then higher order functions. Sorry, it's not type interface, it's type inference. Then higher order functions, then streams. So these advanced concepts will be discussed here. Week 9, it is a continuation of week 8. Again, we'll deal with the concept of streams.
Hello, ma'am.
Yeah,
Hello, ma'am. You will be discuss week one today.
yes. Just after the course syllabus, I'll go into week 1.
Okay.
Yeah.
Okay.
Okay, so in week 9, we'll discuss streams in detail. We'll also see file handling, basic file handling in week 9. And in week 10, we'll move on to more advanced topic like multi-threading. We'll see how to create threads. And also, week 10 is basically a theoretical week where we'll discuss about race condition, mutual exclusion, some of the principles in multi-threading. And in week 11, we actually learn how to do multi-threading programming. We will also see thread safe collection. We'll discuss in detail. Just for now, you understand these are things. And week 12, it is one of the easiest week we have. Graphical user interface. You will see how to create an interface using Java libraries like Swing and AWT. So that's all as syllabus. And in each week, you will see activity question, practice questions, and graded question. You have to practice these questions to understand the concepts and Java syntax in detailed manner. And then you will also have programming questions and graded programming questions. So one is for practicing and the other which is graded, just like in Python. And to practice Java, you can either use online compilers, and I would prefer you use something like Eclipse or VS Code. Okay, and we have quiz 1, quiz 2, OPP 1, OPP 2, and enter.
Ma'am,
Okay,
could you repeat those? So what you just said right now to practice?
yeah, you can either go for online compilers or you can use Eclipse IDE or VS Code or anything. It's up to you. Okay.
Is that a compiler or is it practice questions? What
Uh,
exa- what
Sorry,
exactly is Eclipse?
Eclipse is an IDE. It's just
Oh,
like VS Code. Yeah.
okay, got it.
Yeah.
Ma'am, I
Now,
have a question. Can I ask?
yeah.
So basically, why means I haven't done my programming in data structures and algorithm. So means will I be able to complete this course? Because in the course material, sir is mentioning some of the data structures which I haven't completed or don't know about. So means like how to go about it.
Okay. So yeah, sir mentions linked list and yeah, some of the
Stack.
data structures, and just for as an example, right? I think you can understand it. You just come to live session.
Mhm.
Okay, that will be enough. Not doing PDSA is fine.
Also, means should there be any prerequisites before going through the materials? Like, means I don't generally use classes in my work, so I don't know much about it. Just know the classes and objects. So all those extra concepts that you mentioned, like polymorphism and abstraction and all those stuff. So should I cover that first and then move on to materials, or should I go means like parallel, completing here also and completing that topic also?
What you can do is first you can go through the lecture videos before
Mhm.
coming to live session. So every Tuesday it will be concept summary session. So
Okay.
as the contents are released on Friday, you will have some Friday, Saturday, Sunday, Monday, for some 4 days, right? 4 to 5 days to go through lectures. Go through
Mhm.
lectures, try to understand whatever you can understand from there. Then
Mhm.
you can note down whatever doubts you have. Come to live session. We are going to do the concept summary of the same topics in Tuesday sessions. Okay.
Okay.
So whatever doubt you have, you can take here, and we will also, as we are also going through the same content, we will also include these kinds of things where people who have not done PDSA courses having difficulty in understanding linked list and all, we'll cover it in little bit more detailed manner. Okay.
Okay.
So
And programming courses, programming sessions.
yeah. So basically, our session, how many sessions we will have is Tuesday session will be concept summary, and Friday we'll have a programming session plus concept summary according to the students' interaction. And then again, Saturday we have explicitly a programming session. We call it as live coding session. These are
Okay.
instructor sessions. And
Okay.
again, we have two other TA sessions. TA sessions will be on Thursday and as well as on Sunday. So you
Okay.
can utilize all these 5 sessions per week. You are good to go then.
Okay.
Ma'am, there is a TA session on Sunday.
Yes, yes.
It's not there on the calendar.
Yeah, we will schedule it.
It's
Oh,
there on the calendar. I
I
can see
think it's already there. I
Yeah,
have
it,
done.
it's 6 p.m.
oh, okay, okay.
Yeah, yeah, it's there. Just check it out.
Excuse me, ma'am.
Yes.
Ma'am, the session for Friday, the OPP practice sessions,
Mm.
that is clashing with system command sessions. The system command session has been scheduled for 9 to 11, and the session for Java is from 8 to 10.
So, is the system command session a TA session or instructor session?
Ma'am, it's TA session, I believe.
Okay. So, we basically are not able to, avoid these clashes between TA and instructor session, but we try our best to avoid clashes between instructor sessions.
Okay, ma'am.
Uh, yeah, that's why.
Okay.
Yeah. Okay. So, let's start with week one concept summary. How many of you have gone through lectures? Yeah, good. Okay. Then it will be easy for you guys. So, in lectures, we started with what is programming language, right? So, basically, programming language is used to give instructions to system so that we want our system to do something we are giving in the language that is understood by the computer. But at the same time, when we have programming language like Java, Python, JavaScript, etc., these are languages which actually write in high, which are called as high level language. And the machine can understand only the language of zeros and ones, which is called as low level language. So when we write the program in Python or Java, this is actually in high level language, and the system can understand only machine code, zeros and ones. So there should be a translator that translate this high level language or the code to the low level code. Okay, so we have something called interpreter or compiler that actually does this conversion from high level language to the low level language. So in the case of Python code, suppose we have code like this: x equal to 10, y equal to 10, and print x plus y. This is our Python program, and the translator that we use for Python is Python interpreter, and this Python interpreter will convert these instructions into corresponding machine code and execute. And in the case of Java, Java is a compiled language. Java has a compiler. And one more thing is Java is not purely compiled language. Java
Ma'am,
also,
just a question. Ma'am, just a question. Sorry to interrupt. I'm really sorry. Are you sharing your screen?
yeah, is it not?
So, ma'am, we can't see your screen. That's why.
Till now you are not saying?
No.
No, we were able
No,
to
ma'am,
see
it
you.
was
One
in the
small.
beginning,
Now we
got
can't.
disconnected.
Oh, sorry. Okay. See, I think in between I forgot. Sorry for that. So yeah, I was talking about this Python code, this code, and suppose we have a translator which we have as interpreter for Python. So this Python code will be taken by the interpreter and will be converted into the machine code and will execute. And in case of Java, we have Java compiler. So Java compiler will take Java code and translate into something called bytecode. And again, there is something called JVM, and the JVM will take this bytecode and convert to machine code and execute. So that is a two-step process. We'll discuss this in detail in week 2. For now, you understand we are going to write program in some Python or Java, and compiler or interpreter is a translator that will convert this code into machine code, which is executable. Is that fine?
Yeah, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Yeah. Now, there are different styles of programming. So we can say programming styles as how we can define a problem in some structure. Okay, so different styles. So we have imperative style of programming and also declarative style of programming. So in imperative style of programming, what we actually focus is on how to compute something. And in this style of programming, the instructions that we write to the machine are like step by step instructions. We'll say, take this, do that. That kind of step by step instructions will be written in imperative style. And in declarative style focus more on what the computation should produce. So it's basically like you give something, get something out of it. Give something to a function or a procedure, get the result out of it. We don't care what exactly it is done inside. And also in declarative style, we mainly focus on dividing our program into small functions or smaller computation and combining them together. So basically, it's a combination of small transformation. Transformation, we can say, like in Python, you might have some map function, filter function, etc., which takes some function and range of values, do something on it, get the output, right? So declarative style mainly focus on what the computation should produce. This is theory part. I'll come to programming example. See
Yes.
this example. Yeah. Now, in imperative style, let's see the imperative style. And the problem we have is to find the sum of squares of even numbers up to number n. Okay. Now, in imperative style, if we go for this, we are going to define a function sum square even that takes a number n. And here we want to find sum of something. So we are having a variable my sum and it is initialized with value 0. Now, we want to get the squares of even numbers up to n, right? So we are taking a for loop, and the for loop we are taking this range function to generate the values n plus 1 because we want up to n, and for each value, for each x in this particular range 0 to n, we are checking whether it is even using the modulo operator. If the number is even, then we are going to square it and then add to my sum. And after the execution of this for loop, we will get the sum of squares of even numbers up to n in this particular variable. Finally, we will return the value. So, in this particular style, what you can see some variables that we have used, some intermediate variables. And also, this uses for loop, if block, etc. So, this is the style, imperative style. And here we focus on how we are computing my sum. Okay, and let's compare this with declarative style. In declarative style, you can see we have a small function called even, and this takes a number x, a variable x, and it returns a true or false by checking whether it is remainder is 0 or not. And we have another function square that takes a variable x and it returns the square of x. And again, we have another function sum square even n. Here, this takes number n, and here we are using some other smaller transformation like filter method, filter function, map function, etc. Let's try to break it down this particular return. Here, filter even range n plus 1. So the function that we are applying to filter is even function over the range of values 0 to n. So after this filter, what we will get is a filter object, and that will have, just for understanding thing, it will give us a list of numbers that are even. And then we'll call the map function, and the function to apply is square over the list of numbers that is given or returned by filter. Now, map will apply the square function over the list of numbers, the return value of this particular function, and that will give us squares of those even numbers. Now, to that list, we are calling the sum function. Sum of that particular list of squares. That will give us sum of squares of even numbers. So what we did here, we don't have an intermediate variable, right? We actually divided our program into smaller functions and then used it. Getting it?
Yeah, ma'am.
Yes, ma'am.
Ma'am,
Okay.
I have a question.
Yeah.
Ma'am, so by looking at the both of the styles, both imperative and declarative, can we comment anything on the complexity of the program, whether which is more complex or which whether which will have a higher time complexity like that?
So according to time complexity, I'm not sure much about that. But so according to our requirements, we'll use both styles. So sometimes we'll use a mix of both style, and also if we have a bigger algorithm to compute, or then we'll go with imperative style, and declarative style will go, for example, like an HTML code or SQL queries. These kinds of things will go with declarative style, or mathematical expressions if you want to do something, then we'll go with declarative style.
Okay.
Okay.
Hello.
Yes.
Ma'am, one question. From declarative, what I understand that you do not have to mention the steps what you have to take. But for example, in SQL, that is also a declarative language. In that, we do not tell that go into this index, each index, and then look for a particular column, and in that you have to do. We just tell some property, and it gives us the result. But here, what I am seeing in the declarative in Python, it is just a functional program which is broken down into some smaller programs, and then it is giving us. But here also we are mentioning what is even is that is giving us reminder to 0 when divided by 2. What is a square? Just squaring that. So we just simply broken down it into smaller function and then applied functional programming concept. So ma'am, I'm not getting how to differentiate between declarative and imperative. Hello.
Python program. Yeah. Am I audible?
No, ma'am. I was not able to hear you.
So here we are showing this particular program in order to show what is declarative approach in Python programming. Okay. Did you get that?
No, ma'am. Like basically, what is understanding of declarative, that you do not have to mention steps, what steps you have to do. Am I right, or
Yeah.
there's
Yes,
something
yes, you are right.
here?
There
Just
is
you are,
nothing like,
yeah.
yeah, continue.
And here you are just breaking it into smaller programs in which you are telling that what is even, what is a square, and then using map and filter function.
Yeah. So basically, you see, we can't say there is something like step number one, step number two here, right?
Yeah.
Which makes it not imperative. And we are not saying something to do. It's like we are using some of the existing functions here, and also some of the we have declared some of the function, and just utilizing those functions, and we are applying some of the transformation operation rather using some intermediate variables or for loop or while loop. We are not using any constructs. So this is declarative.
Ma'am, would it be possible to say because over here we had to define the square function and the even function, but in a case where it's already been defined for us, then it just becomes your only code is that def sum square even. So that is basically just telling it's exactly what declarative means, right? It's just an instruction that you're giving the computer where you're saying that whatever is even you have to square it within this range.
Yeah, yeah, right. This explanation is better. So you just give the number, get it, and you are not saying what to do. Is that clear? Uh, one who
Yes.
had doubt.
Question. Yes, we are actually defining what we have to do, right? So then why two ways are there?
Why two ways are there?
Like imperative and declarative. In both, if you see, though we are breaking it down in two different ways, one we are writing it in step-by-step manner, another in functional manner, but actually we are defining what we have to do. We can't say that an even function exists. It has to be defined somewhere, and then we can use it. So in both the steps, we have to actually define the function itself.
Yeah, but still, declarative is more abstract. So when you use this particular function, sum square even, when you are using map and filter, uh,
Hmm.
you don't have to know the implementation of map function or filter function to use it, right? It's more
Yes,
abstract.
yes.
We are not saying how filter is defined somewhere.
Mhm. Okay.
Yeah. Any other doubts? Okay, then moving on. Yeah. So now we will move on to, okay, from now onwards you will see the topics are like we'll have some variables, we'll talk about dynamic typing, static typing, okay, and then we'll move on to basic intro to collection these things, then we'll come to memory management. Just to understand the flow, I'm saying this. Okay, now we are at variables. So after learning about programming, what is programming, then we saw programming styles. Now let's see about variables. So what is variable?
It's a memory location with a name in the code where you can store information.
Yeah. So we need variables to refer to some location in the memory, right? So that we can use that again instead of getting the bit and bytes, those kind of terms. So we are naming the value 23 with n. Basically, n is storing 23. You can say in that manner. And this is a Java syntax. Here you see int, right? So in Python, you might be seeing something like n equal to 10 means the variable n is pointing to value 10 in the memory. And if the value is 10, then it is an integer. So from the value that is assigned to variable n, is my screen visible?
Yeah, ma'am, it is.
Oh.
Yes.
So from the value that we assign to a variable, we infer the data type, right? So let's see that. One more thing. Here you can see n is the name of the variable and 23 is the value and the data type is int for integer. Okay. Now there are two different types of uh, typing, which is dynamic typing and static typing. So these are the ways by which we handle different variable types in different programming languages. if you know, Python is a dynamically typed language. So let's see the difference, and you might be already knowing this anyway. The same thing. So here we have x equal to 10, and we have not specified what is the data type of x. Rather, we gave the value 10, and from the value 10, it is inferring that the data type of x is integer. And after a point, like in the second line, if you write x equal to 7.5, now the data type of x is float, because 7.5 is a float value. So from this value, now the data type of x is float. So it allows to derive derive the data type from the value that is assigned currently to that particular variable. And you always have the provision to change the values to the variables in Python, because we are not naming it beforehand. In advance, we are not saying that this variable is going to store this and others are not allowed. Rather, we are like it's a free bird. Now, first x equal to 10, it is an int. Later, it is 7.5, it is a float. That's allowed. Now, this is called as dynamic typing, and we can say it is done at runtime. And now comes the other typing, it is called as static typing. And static typing, we have to give the data type in advance with the name of the variable. So when you declare x as int, this means that x is expecting an integer value. And if we declare a as float a, then it is going to take a float value. It is going to store a float value. At the same time, if we try to assign x with 7.5, x is int, okay, then it is not legal. It means it will give you an syntax error, because we are trying to assign float to a variable that is expecting an integer value. Getting it?
Yes, ma'am.
Yes.
Yeah. Now, uh, as we have different types, the different types has its own advantage and disadvantage. One advantage of static typing is we can catch the bugs earlier. If there is something like we are involving some data types and calculations, so we can get the compiler error, the syntax error, while we compile. So that is one good thing about static typing. Okay, and in the case of dynamic typing, we can say the flexibility itself is its advantage, right?
Yeah.
Is that fine?
Yes, ma'am.
Yes, ma'am.
Okay.
Hello, ma'am.
Yes.
Ma'am, in dynamic typing, we get the error at not runtime.
Yeah.
And the
So in
syntax
dynamic
error.
typing, yeah. So this will be taken in runtime only, because the data type itself is determined at runtime. At the same time, for static typing, the data type determination, so the type checking, is done at compile time.
Okay, ma'am. Thank you.
So Java is what does it follow? Dynamic or static? It
Static.
follows
Static.
static type,
Static.
right? So next, let's go with the collection, abstract data types, object-oriented programming. A small intro. So there are collections like array, list, etc. What is the use of collection? We can store multiple values into a single unit, right? You might have already seen list. We can store like values 2, 3, 4, 6 into a single variable. And abstract data types. So what is abstract data types? I'll come to this later. Let's go with memory management first. Okay.
I have a question. In Java,
Yes, yes.
if we have arrays in Python, we can store any data type in an array. Is it same with Java or is it different?
It's different. We specify the array with the data type, and then we accept the values.
Okay.
Ma'am, is it static
Yes,
versus dynamic over?
yes.
Ma'am, one question from the lectures. The professor said that static will run faster than a dynamic type programming language, and he gave two reasons. First, he said that whenever you declare a data type in advance, it will optimize in the compile time. And second, he said, second, that is understandable, that if you do not declare the type, then in the runtime it uh, calculates what is the type of every variable, so
Yeah.
it take time. But how optimization happen, if you can explain, or we will study that later,
How
if
the
you can give
optimization
some hint.
happens.
Yeah, if we declare variables earlier.
So yeah, okay, I'll let you know whatever I know. So in dynamic typing, why it is slower? Because we are checking the run type at runtime, right? And in static typing, as we are doing this in the compile time, it is little bit faster compared to the dynamic typing. And the optimization part, I'm not sure about this. I'll take you to this. I mean, take this topic to the next session. Okay, I'll note it down.
Okay, ma'am.
So yeah, any other doubts?
No, ma'am.
Yeah, one more thing. So before every session, we'll post in the discourse about collecting the doubts from you guys. So you can always post your doubts over there so that we can go through those doubts and prepare in advance and come to the session. So these kinds of special topics, if you want something, you can put it over there. Okay.
Yes, ma'am.
Next, yeah. Next, we are going to learn about memory management, another concept. So, yeah, one more thing. Have you like do you know about local variables and global variables?
Yes, ma'am.
Yes, ma'am.
Okay. So, what is local variable? In a function, let me have a Python code. Suppose we have something like x equal to 5, and let me have a function f, and then another variable y. Let me print y here, and also try to print x here. Let me call the function, and here I'm trying to access x and y. Okay, so see here we have x equal to 5, and
A global
Global.
variable.
this is a global variable.
Global.
So this is outside a function. So this is a global variable which can be accessible from inside the function as well as outside the function. And this y equal to 5 is a variable, local variable. So this particular y is accessible only inside this particular function. Okay. So we can say one more thing here. The scope of y is limited to this particular function. So what is scope? Scope means where the
Accessibility.
variable is accessible. Yeah, right.
Accessibility of the variable.
Right. The accessibility of the variable y is limited to this particular function. Okay. So y is local variable, and I'm trying to, okay, let me see here. this we have print y and print x trying to print y. Is this okay? If we can we print y here?
Yes, yes,
Yeah.
Yes,
What about x?
yes.
we
Yeah, we
can
can.
do that.
Yeah, x is also fine because it's a global variable. We can access it here. And uh, so here in line number 7, we are calling function f. So after let me keep this different. So here we'll get output as 10. First it will be 10 and then it will be x which is 5. So 10, 5 and we'll come back here after calling the function. We'll exit from the function and come back to the main. So here line number 8 will be executed and x is a global variable. So here again it will output 5. Shall I try printing y here? What will happen? We'll get
Error.
error
Error.
because y cannot be accessed outside the function. That's why it is called as y is a local variable, local to the function. So what is the scope of y inside the
Local.
function?
It's just function.
Yeah. Okay.
It should it should show some other kind of error. It is showing syntax error. Why?
Additional dot is there. No?
Oh yeah.
You're lagging.
Excuse me, ma'am. You are not audible.
So slow. Yeah. Oh, is it now?
Yeah, ma'am.
Yes.
Right now you are audible. Better, ma'am.
Yeah. So this is the error that we are going to get. Okay. Name y is not defined. Okay.
Yeah.
Now let's go back. That's about local variable and global variable. And let's see the different part of memory. Okay, we have stack memory and heap memory. And these local variables inside a function, all these variables are created inside the stack. Okay, and the objects type dynamic allocation, which is done at runtime, those allocation are done in heap.
Ma'am, what are these two?
Sorry,
What are stack and heap means? Like how they look?
how they look in the sense.
It's like what is the structure? How they in a stack? What I assume is like it will be top down, a container type of thing, and heap will be like multiple nodes there.
It's sequence of bits actually.
Okay.
Ma'am,
Yeah,
stack is
it's
that
not
first in
the
last
data
out, no?
structure that we. No, no, no. So this stack and heap is not the data structure. Okay, this is just
Okay,
memory.
okay.
So
Yeah,
what goes into a stack and heap? What you said?
yeah. So the local variables that we create inside a function, those will go into stack,
Okay.
and the objects which is created at runtime, those will go into heap. I'll come into
Okay.
Sorry,
detail.
ma'am. You were
So
not
Ma'am,
audible.
in
can you
What
memory
repeat?
goes into
management,
Your
heap?
we
voice is
basically
jarring.
deal with
Yes.
how to allocate and deallocate
Which
memory
variable will
for
go to
different
heap?
kinds of variables or objects, etc. Okay,
Ma'am, can you repeat? Your voice was jarring.
Ma'am, what created in runtime goes to heap?
voice is breaking.
Yes, ma'am.
Yeah, ma'am.
One minute.
Yes.
Let me change my place for a minute. Is my voice audible now?
Yes, ma'am.
Yes.
Yes, ma'am, it is clear.
Okay. So into stack, we will add the local variables. Local variables, when we call a function, activation record, all these will be pushed into the stack. I'll come into detail. And into heap, we will add all those objects or the linked list, dynamically allocated memory. All this will go into heap memory. And also one more thing you can see is heap is used for dynamic allocation, which means that those which is done at runtime.
Ma'am, here stack is not that related data structure, no?
No, it's not the data structure, it's just part of memory, or we can say some areas of memory, region of memory, or just we call it as stack and heap, and it's not the data structure that we are referring to.
Okay, okay.
Now, we have seen the scope of variable, right? Let's go into this program, and yeah, it will be clear once I talk about like some of the things. All in all, it will be clear. Okay, just trust me. Let's go one by one. Scope of variable. Now we have function f, and this takes a list L, and here we have for loop that takes for x in L, for each element in L, y equal to y plus g of x. And here again we are calling another function g. And when you call g, again here we have another for loop that also use variable called x. And now see, when you call this function g here, okay, g here, and we are here now, right side, and when you refer to this x inside this for loop, so that x will be not this x, okay. So we are actually in this particular function, and the x that we are referring here will be of function g, not of function f. So, and also we can't even get access to this x from g, x of f from g, because the scope of x is limited to this particular function. Are you getting it?
Yes, ma'am.
Yes.
Yeah. At the same time, one more term, lifetime. So even though we are here in this g function, and we are not able to access this x from g, is x dead?
No.
No.
No, it's in
Still,
the X.
yeah, it's in its own activation record. We'll come to that point. Okay, so it is still alive. So the lifetime of this particular variable is different from the scope of variable. So lifetime means how long the storage remains allocated. Okay, and lifetime of x in f is till f exits. So when this particular function exits, then the lifetime of variable is gone. It's not alive anymore. Getting
Ma'am, I
it?
have a question here.
Yeah.
Means for
Yeah.
x in L, y is equal to y plus g of x, and this x is the part of this loop which
Yeah.
iterates on the L, which is the input to the function of f of L, right? So this
Yes.
x should be the part of this f of x till now here.
Yeah.
After that, once we call g of x, it goes to our g of m, and m is referenced as our x.
Yeah. The
So
value from that
for
list.
so for x in range of, if we represent m as x, right? So x in range of x, then how, means like how it works then after that?
X in range of x.
Because g of x is the input to our function g, right?
Yeah, yeah. So
So
here
instead
when
of
we
using m, I am just using x.
are using x in range as well as here.
Yes, yes.
Uh,
So wouldn't it cause any trouble or issue?
so if you use x here, then it won't cause any error, I think, because still it will take range of values, and that will be an iterable range object, and we can iterate through that using this variable.
Okay.
Okay, so hope you understood the lifetime of variable, how long the storage allocated to a memory, allocated to variable exists. That's it. Is that fine?
Yes, ma'am.
Okay. Now comes to the main part. So to deal with these things, so we have x here, we have x here, and while we execute the program, how this is done in the memory is discussed here about activation record. So for each function call, when you call a function, an activation record is created and pushed into the stack memory. So activation record is kind of a small part of stack. So for each function call, an activation record will be created and pushed into the stack. And this activation record will have some information related to that function call. It can be the local variables inside that function and some other things. Let's see with this particular example, factorial. So hope you know the factorial, the
Yeah.
recursive function for factorial. Are you okay with that? Factorial of n.
Yes.
If you call, then if n equal to 0, then return 1, else return n into factorial of n minus 1. Okay? Yeah. So for that function, when you call factorial of 3, it's a function call. An activation record for that particular function call will be created and pushed into the stack. So this yellow part. Okay? And the variable is n and the value is 3. And inside the function, again, it will go to the else part, right? So the else part will be calling to factorial of n minus 1. And we are expecting a value over there, as it is a recursive call, as it is a function call. Again, another activation record will be created for factorial of n minus 1 and pushed to the stack. Okay, so that is because we are calling for n equal to 3 here, this will be factorial of 2. So storage for factorial of 2, another activation record is created and value n is 2. Again here we will call factorial of 1. So this is the function call, and as we are relating one over other, as it is a recursive call, there should be a connection between these function calls, right? For that, to have that, what we can say, the relation between these functions, we have control link. This control link will point to the previous activation record or the function which called it, the callee function. It's also called as callee function. So control link will point to the previous activation record. As factorial of 2 is called by factorial of 3, so control link is pointing to the previous activation record. And also here we are expecting a value from factorial of 2, this function call. So we have something called return value link that will actually point to where the result of factorial of 2 should be stored. Getting it?
Yeah, ma'am.
Ma'am, can you explain the last part, like return value link? Can you explain?
Yeah. So factorial of 2 is going to give us a value, right? Which will calculate the factorial of 2. In turn, okay, I'll go the detail. Factorial of 2 will call factorial of 1, and again factorial of 1 will return a value. That value will come here, and the value that is returned by factorial of 2 should go to here, right? So whatever the function generates as the output should go back to the previous call. For that, we need return value link.
So it's kind of a pointer.
Yes, yes.
Which points to which location it has to
Store the
allocate.
value. Yeah.
And factorial n minus 1 will terminate at 0. So that's why means like we will get a return value link which will be linked to factorial n minus 1. Blank space is there after that.
Yeah, yeah.
Okay.
So more activation record will be here for factorial of 1 and factor. Yeah. That will come here, the value will come here, from here it will come here. So
This is for a function, means like here we are using a recursive function. But
yeah,
what if we don't use any recursive function? Then how this stack will look like?
same. So suppose we have main function. So main function will have a part in stack, and from there if we are calling some function, activation record will be created. So now the controlling point to the main function.
Okay.
And return value link will be where we have to store that value in the main function. So each function needs storage for local variables. We create activation record when the function is called. Activation records are stacked. And when the function exits, this activation record will be popped out. Okay, it will no longer exist. And purpose of control link is to point to start of previous record, previous activation record, and return value link tells where to store the result. And now,
last value will be popped out, right?
yes, the last value will be popped out. So let's see scope and lifetime using this activation record. So variable in activation record at top of stack. So we can say if we are in this activation record, then the scope of n will be in this particular activation record, right? So which is at the top of the stack. And for lifetime, so we can see lifetime of n will be till all of this exists, right? Till it get popped out of the stack. So these are the main things related to activation record. Is that fine?
Ma'am,
Yes,
can you
ma'am.
repeat the scope one again?
So
I
here,
didn't get.
yeah. So the same concept of scope using activation record. Now we can say, consider this activation record for factorial of 2. So when you call factorial of 2, then what is the scope of n here? It is limited to this particular activation record.
Yeah, okay.
Yeah.
Okay, got it.
Yeah. So we just saw here with the program, and here how it is actually in the memory. Shall I go with the next topic?
Yes, ma'am.
Yes, ma'am.
Thank you.
Yes, ma'am.
You want to read this? This is same. Scope of variable is part of program in which the variable can be accessed, and lifetime is how long the variable stays alive in the memory.
So this lifetime of variable will be the same even if the value of the variable is changing throughout.
Yeah, lifetime means how long we can access the variable. The value is fine, whatever the
Okay.
value. Yeah.
Okay, got it.
Now let's continue with the stack itself, this activation record and all. We'll come to heap at the end of this topic, okay? Now, two different ways by which we can pass arguments to functions. One is call by value and the other is call by reference. So in call by value, what exactly happens is we actually copy the value into the function arguments, and if you make any changes to those values, it won't affect the original one. And in call by reference, we actually gives the memory location as it is. So it's like we are giving the actual value. So whatever changes that you make to that particular variable will be affected in the main function as well. Or we can say it's the same thing we are passing the reference. So we can see the change in the function as well as in the main function from where it is called. So I'll take you through one coding example. Suppose we have some function like update x, and I'm updating x as 10 and printing x. Let me print it. inside the function. Now let me have a variable a equal to some 5, and I'm calling update function on this a, and here I'm printing outside the function variable a. So let's trace this. So here line number 5, execution starts from here, a equal to 5, okay, and we are calling update on a. So now we reach here in the function, and the value of x, what will be the value for x here? X will be equal to a equal to
10.
5.
5. And then in here we have x equal to 10, and here we are printing value of x. So here x value of x is 10, so we are getting x as 10. And here outside this line, outside the function, if we are trying to print a, we are getting the value of a as 5. So it has not updated the original a, right? So this is called as what?
Call by value.
Call by value. Now let's take some mutable type. Let's take a list. And adding value to the list. Inside the function, print the list, and let's take a list L equal to 1, 2, 3, and here I am calling update function on this list and printing list here. So in line number 5 we have a list L equal to 1, 2, 3, and in line number 6 we are calling update of L, and in update what we are doing is we are adding one more number at the end of the list. So when we are passing this L to list, we are actually passing the value or reference. We are passing the reference. We are actually passing the memory address of this particular list. So this list is not separate from this L. Both LST list and this L, both are going to point to same list, this particular object. So when you make change using this particular LST here, appending 4, and here we are printing list, anyway we will get 1, 2, 3, 4, and at the same time outside the function, if you are printing this particular L, as the list is same, as we have made the modification in the original list, we are going to get this output. So this is why it is said that it has side effects. Getting it?
What is the difference between this and previous code? Both time we are creating a variable, giving
Ma'am,
it a value and updating it.
No, see here. Earlier, when we tried to print the value after the update operation, we didn't get the updated value inside the function. What we got is the original value inside the main function. But here as we
That
pass
was an
the
integer.
call by value worked for primitive type, and for this mutable type reference type, it didn't work. Here it
Okay.
is call by reference. So when you pass argument list to this particular function, it is called by reference.
So similar thing can happen with dictionaries also, right?
Yes.
Because they are also
List,
mutable.
dictionary, set,
What
etc.
about tuple? Tuple will not have this because it's immutable.
Yeah, only for mutable types.
We have this call by reference.
Yes.
Okay.
Is that fine? So let's see this particular code here. This is actually a combination of both. Suppose we have a function f that takes some a and l, and here we are passing we have x equal to 7 and my l equal to list 8, 9, 10, and here we are calling function with this particular x and this my list. What happens? A will be equal to x. So when you call this function, what exactly happens is the value of x will be copied to a, and L will point to whatever my L is pointing to. You see the difference? The value of A will be copied, value of X will be copied to A, and also here this will be like both are pointing to the same type, same list. Getting it?
Yes, ma'am.
Okay. So this is the concept of call by value and call by reference. Now that's about stack part and functions and local variables, call by value, call by reference. Now we will learn something about dynamic allocation, dynamic memory allocation in heap storage. So the other part of memory was heap memory, right? So this is basically used to allocate objects, arrays, etc., which are actually created during runtime. And in language C, we have something called a malloc function to create this memory in heap. And to deallocate, yeah, one more thing I left is in stack, whenever the function exits, you know that the activation record will be popped out and nothing will be in the memory, right? Keep in mind. And for heap storage, what happens is when you allocate some memory into the heap, you have to, for the deallocation purpose, you have to manually do it in programming language like C. And for Java and Python, we have something called garbage collection. And also, I said this, along with this, the objects in heap memory or something that we create in heap memory are called as like persistent. So they will be in the memory as long as we don't clear it out, or some automatic garbage collection algorithms works or some technique works. Any doubt?
No, ma'am.
Yeah.
Second line,
So,
deleting a node in linked list, delete node, I now dead storages. This line means like, what is this?
How do we return a new storage on the heap? Yeah. So, okay. So, suppose we are creating a linked list. So, in linked list, we have multiple nodes, right? Nodes will be created one by one and added to the list, and finally we'll get a linked list, and it is done at runtime. Size will not be fixed. We may change it at runtime. Keep this in mind. Now, so in C programming, suppose we are using malloc to allocate the memory. So this is a function in C where we use it to create dynamic memory allocation. We allocate the space for the linked list.
Memory, allocate memory space.
Yeah. And now, after we delete it, here it says that this particular node is now not reachable. Okay. And in that case, how will we return that unused space? So that will be like something is there which is not used, and it takes our memory, right? Wastage of memory. So in that case, what we can do is we can free that pointer, free that memory.
Okay.
So in C programming, we have something called free method to clear it out. Okay. And in case of Java, Python, these kind of languages, we have something called automatic garbage collection. We have some methods related to that. Yeah, and there are certain algorithms that we use for this to clear up unused uh, memory space. So one is mark and sweep, where it will go and check whether something is there which is not referred, no longer referred by any variables, which means this is not needed anymore. So such kind of objects will be taken and just freed. So in C, this is actually a manual memory management. The programmer has to explicitly go and delete it. And in Java Python, it is automatic garbage collection. This will be running. Clear?
Ma'am, here whenever we are talking about memory, we are talking about the volatile memory, right?
Yeah, RAM.
Okay.
So why actually we need heap memory? Can we create a linked list in stack itself? So how linked list is created? We'll have some certain functions, right? So after the function call, we create the linked list, and as per stack, after the function exits, we lose the space allocated for that particular variable or anything. And for linked list, we can't do that. We want this linked list to be in the program throughout its running. So we use heap storage for that.
So stacks clear up the memory while heap keeps it till the runtime.
Yes, yes. Shall I move to next topic?
Yes, ma'am.
Okay. So it's called as something called modularity. Simple only. Let's see. So you might have heard of divide and conquer method, right? Suppose we have let's take an example of studying a course or subject. How will we do? Anyway, our course itself is divided into some 12 weeks, right? Divided into some 12 weeks. Again, in 12 weeks course content, we have each week has some 6 or 5 lecture videos. We again divided into lectures. So we basically divided a bigger thing into smaller parts, and we are trying to work on it, right? Let's take this analogy into programming side. Suppose we have to develop, we have this particular task to print first 1,000 prime numbers. Okay, so this is our main task. A begin and end you might have seen somewhere. So begin the task, end the task. So this is our task, print first 1,000 prime numbers. So the big task we will divide into some smaller subtask. So first what we'll do, we'll declare a table P, and we'll fill this table with, we are saying that we'll fill this table with first 1,000 primes, and then print the table P. This is like now 3 steps, 3 subtasks. We haven't yet declared or given the instruction on how to create this particular table P. See the next one here. Here we have created an array which actually denotes our table. The size is some 1,000 and it's an integer array. And then for this particular line, this particular subtask, fill table P with first 1,000 primes, we are actually running a for loop for k from 1 through 1,000 algorithm. We are going to make P of k equal to kth prime number. So we are going to take each of the prime numbers and add as element to this particular integer array. And then that is for the second line, second task. And for the third task, we are again elaborating how to print this table P. So here we have actually this is an array. So we are again using a for loop running through 1 through 1,000 and print each of the elements, each of the prime number stored in that particular integer array. So what we did, we had a task, we divided into subtask. Again, we elaborated the subtask so that uh, we finally get the output as desired. Getting it?
Yeah, ma'am.
Yeah. Same thing we can apply in software development, right? Suppose we have to develop an application. one can do the backend part, the front end part, database. So these tasks can be divided into different individuals and they can work on it. Finally, we can combine all this together, get the app or anything. Now, what is program refinement? Focus on code, not much change in data structure. So program refinement is where we refine or make changes in the code we have. Okay. We are mostly focusing on the code, but not on the data structure. So in every program, there are two parts, right? One is the data and the algorithm itself, or we can say the step of instructions that act on this data. So we can't separate it out. Either it's together always, data and the instruction part, or we can say the logic part. So in the program refinement, we focus on the code, but not on the data structure. We can make changes in the code. We can change the logic for this particular for loop into a while loop or something else, but we won't change the integer array. So that kind of changes to the code is called as program refinement. Fine.
Yes, ma'am.
Okay. Next, data refinement. So data refinement is opposite of that. We'll make some changes to the data structure, not on the code, but it will affect the code, so we have to make some changes. So this example was explained by Prof in lecture. Should I repeat that, or have you gone through the lecture?
Ma'am, I have gone through the lecture, but means like what sir said is that if we change the way we want the functionality that we want, we have to change all the functions. Like, say for print statement,
Yeah.
earlier we were directly printing the statement, but now if we want to print a transaction, then we have to handle the cases of deposit, withdraw, create account, not create account, deposit and withdraw also.
Right. So
So
as
what
we
is
are changing
cascading
the
effect in that?
print, yeah, kind of cascading effect. Yeah.
No, no, I
So
want to
if
know
you
what
want
is that.
to, so yeah, so print statement earlier the print state. Okay, let's begin from yeah. Suppose we have to store the data of or the account details of some 100 customers. Okay, so we are using an integer array. Suppose we have a simple integer array and we are storing only the current balance, only the current balance. So in that case, if the data we have is only the current balance, if we call the print statement, we are going to get only the current balance. Okay, and for the deposit and withdraw, the instruction will be just print the current balance. Okay, and for the deposit and withdraw, the instruction will be just print the
Ma'am,
And
not
current
you're
audible.
not
balance. Am I audible now?
Yes,
Yes,
ma'am.
ma'am.
yes.
Yes, ma'am.
Okay. When did I lose?
You were telling about print statement.
1 to 100.
Okay. Okay. Suppose we have an integer array. Okay, some 100 customers in a bank, and the value that is stored in this particular array is just the current balance of that particular customer. Okay. In that case, deposit will just increment that particular index or the value at that particular index, and withdraw will just decrement the value, the current balance. And print statement will just print the current balance, the basic thing. Okay. Now if we want something more from the print statement, which means it include print transactions, where we want to get all the transactions that has happened or we can see the history of the transaction, just like we see in the Google Pay. Now, just by increasing the amount in deposit or decreasing the amount in withdraw and just getting the current balance is not enough. So in that case, we have to store all the details of all the transaction. So the data representation itself should change. Just by using an integer array, we can't keep track of all the changes, right? So we have to make changes in the way we store the data. Instead of storing it in the integer array, we have to see some other data structure. Getting it?
Yeah, ma'am.
Yes, ma'am.
And
Ma'am,
now
what's
print statement,
cascading then?
yeah, cascading effect coming. So in print statement, we are expecting it to print all the transaction, right? And if we want all those details here, the deposit and withdraw should not just increment or decrement. Rather, it should also give some way by which we can store the history of this transaction. So when you want to change the print statement, we actually have to change the withdraw as well as deposit. So that is cascading effect. Getting it?
Ma'am, could you repeat that?
Ma'am, like a
Yeah.
chain reaction, right?
Like a chain reaction. Yeah. So if you want to change print statement in such a way that we get all the transaction, we want the deposit not just to increment the amount. Rather, we want some, suppose you take some other data structure, we will write or store the value like this particular transaction happened. While someone does the deposit, it will increase the value. Along with that, it will add this message, this particular transaction happened. So that will help us to get in the print statement. Understood?
So we don't want to lose the old value.
It's not like losing the old value. We don't want to lose track of the history. We want to store all those logs, kind of.
So there will be more than one variable in deposit.
Not variable. We can store it as a message or something, a string array or something like that.
Okay.
Or yeah, it will be according to the implementation. We can also use some variables and get all those.
Okay, ma'am, got it.
Yeah. So that is data refinement. Okay, so again we are coming to modular software development, similar to what we learned in uh, stepwise refinement. So here it is talking about how we develop a software. So how can we do that? So using this refinement, we can divide the solution into components. This you can relate with maybe some Amazon application or something like that, where we have multiple things in the same application, right? So in the case of Amazon, what we have, order thing and the list of products, listing thing, and going into the payment gateway, that is a different component, many components all together, right? So what we can do first we can build a prototype, a simple design of each component, and then these components, what are these components? Consider the smallest component, login page. Okay, this component itself can be described in terms of two things. One is interface and the other is specification. What is this interface and specification? Let's try to understand this using function. Okay, this is similar to function. So in the case of the even function that we had, what we did, we passed a variable and the even function returned true or false, right? So we don't know what it did inside. I mean, we don't have to take care or worry about how this function works. So that is the specification. How the function works, the behavior of the function is called as specification, and the interface means the function call itself. When you call even of 5, that even of that bracket, that can be called as the interface, which is visible to other components, other functions. And how does that do? That is not at all something that we have to worry. So interface is something that is visible to other components, and specification is the behavior of the component. Even if the behavior of the component or the implementation of the function is modified, it shouldn't affect the interface, and it won't affect the interface because we are not changing the interface. Only the inside part will be changed if you want. Getting it? What is interface and specification?
Yeah, ma'am.
Okay. So interface, see here. Suppose in the case of function, we have for interface, we can say the function header, arguments, and the return type can be considered as the interface. And the specification is the intended input output behavior, which is the implementation of the function itself.
So when we call in
Now,
function,
here, yeah,
so when we
yeah,
call
ma'am,
a
continue.
function using some of the parameters, is it the interface that we are interacting?
Yeah, this is just an example, simpler example. This is not the exact interface in Java, okay? So this function analogy is used to understand about what is interface and what is specification. So you asked when you call a function, the function call is interface, right? So we can say the function name along with the argument names. This is the interface that we know. Consider the map function. So map function input, it takes some function as the first argument, and the second will be some iterable, right? So we can say that the interface is the map function. Map is the name of the function, and it will take two arguments. One is a function itself, another function, and the next is an iterable object. And how map does the mapping is not our concern. Understood?
Yeah, ma'am.
Yeah. And here we talked about specification. Specification is like not coding exactly, but rather before coding, designing kind of thing. You might be knowing class diagram, UML diagram, right? Are you aware of that? Suppose we are developing a software, an application. First, what we'll do, we'll consult the clients and get the requirements from them, and we'll see what are the components that is required, and then we'll have a pictorial representation of what are the components like login page, database, some payment gateway,
Yes,
etc.
the class CLI
So
mod. Yeah.
yeah, that is called as specification. That is one way of doing specification. There are many other ways. So after getting the specification, we can go into coding. Getting it?
Yeah, ma'am.
Yeah. So that is about the modular software development. Anyway, we will divide our software application entirely into different components, and we'll build one by one using all team members in case of we have a team. Is that fine? Shall I move to next topic?
Yeah, ma'am.
Next is object oriented programming. So till now we discussed some of the concepts only, and now again it is concept. We will not enter into programming part, but still. So object oriented programming. So C is a procedure oriented programming language. Python, Java, these are object oriented programming languages. We deal mostly with classes and objects. Okay, and yeah, let me go with the abstract data types that we left earlier. What is abstract data types? So here you see stack abstract data type, queue abstract data type, and now you know what is interface and what is specification, right? So I said specification is not something that we have to worry about, right? So stack abstract data type, it's like a data type so that we can use to store values, and it will define as what we can store and some of the operation that we can do on stack. So there will be a limit on the operation that we can do on stack. For example, Yeah, this is like in stack. I just remember you are stacking up books. So when you stack up books on the table, which comes at the last on the top will be popped out first. Last in first out principle, right? So basically, in a stack data structure, even if we implement this using an array, internally, even if it is an array, we will restrict the functions or the methods to operate on stack as push and pop. Push to add value on top of the stack, pop to retrieve the value from the top of the stack. So abstract data types are data types that will help us to store values, and there will be some functions that is coming along with this abstract data types. And the internal structure of the abstract data types can be changed. Now I did with, I was explaining with an array, right? We can change the implementation to some other data structures, some other implementation. Still, the push and pop will function just like I explained it earlier. Push will push into the stack, add to the stack, pop will pop out from the stack. So that is why it is called as abstract data types, because we are only focusing on the interface, the push and pop, and the implementation part we are not considering. Getting it?
Yeah, ma'am.
Okay. So one more thing here discusses queue, and also say discussed about priority queue. Priority queue is also an abstract data type where we can store values, and the values will be having a priority associated with it. That is a specialty of priority queue. You can just understand, right? That's fine, right?
Yeah, ma'am.
Sorry. Now, uh, we've reached here. Again, objects are like abstract data types. Here again, an object will have some variables to store values, and it will also have some methods that is specific to that particular object. So we can say it is also an abstract data type. We can also change the program for the functions inside an object. Basically, it is class. We'll come to that. Hidden data with set of public operation, all interaction through operation. Now, yeah, class and object. Let's see this. What is a class? Class is just like template for a data type. How data is stored and what are the functions that is available to manipulate the data inside a class. That will be defined as a pack inside the class. And object is the concrete instance of template, which means this class will not be allocated any memory. For class, we won't allocate any memory, but for object, a chunk of memory will be allocated. Okay, and each object will have separate copy of its own local data, and we can invoke the method of these objects on this particular data. I'll come to this particular example. Suppose we have class car. This is Python code again. I think we had week 10 we discussed this, right?
Yeah, ma'am.
Yeah. So in class car, we have this variables brand, color, and this is the function or method. When we come to functions of a class, we call it as method. Now brand and color are variables for this particular car, and this is class, this is a template. So I would like to use this analogy of where you get some form to fill in. You will have this name, age, roll number, marks, etc. Maybe you are joining to a new college. Now, for each student, you will get this form, right? And when you fill the data, then that becomes your data and your object. You can think like that. So the template itself can be considered as the class. And when it is specific to you, then it is an object. Now that has some value. Okay, just for understanding. And here you can see this is constructor, and you will assign the values for brand and color, and this is the function drive, just print driving. This is the definition or creation of class, and here we are creating the object. When you say C1 equal to car and give Ford and white, the Ford will go to this brand. Brand will have the value Ford and color will have the value white. And when you call C1 dot brand, we are calling object C1 and uh, trying to access the value brand. Then you will get the value Ford and print C1 dot color will give the value white. So here C1 is the object and this is the object, and each of the object will have its own copy of local data, right? So for C1 we gave the value Ford and white for brand and color. So C1 object has Ford white and it has this function drive, and C2 is another object, and C2 is again created using class car with values BMW and red and printing out values brand and color. And here we have another object C2 separate from C1. It has its own copy of data. So these are allocated in the memory. So are you getting it?
Yeah, ma'am.
Okay. Yeah. Now come back and read this again. Class is template for a data type. So we can say that car itself is a data type, an abstract data type that has data and methods. I can change drive here and still I can call drive from here and we will get the new definition of drive.
Ma'am, those brand and the color, are they properties of car? We generally call them
Yeah.
properties, right?
Yes, yes. And this can be called as properties or attributes
Okay.
or instance variables.
Okay.
Yeah. So while coming to Java, we'll use this term called instance variables for the variables inside a class. Okay.
Okay.
And these are methods. Now,
Ma'am, can we say that the class is an interface?
we can't say class is an interface. We have something called interface separately. So it's better not to call class as interface. You can
Okay.
say class as template. It's an abstract data type that can be said.
Okay.
Now, yeah, some of the features of object-oriented programming: abstraction, subtyping, dynamic lookup, inheritance. Let's see what is abstraction. So, abstraction is something like, you can say it hides the implementation details and showcase only what is necessary for the user to see. So, a very good example is brake in our car. So when we apply brake in a car, the car stops. But we don't know what exactly happens inside, right? So that can be called as abstraction. So we are focusing only on the functionality of brake, not how it works. Okay? And here again, same thing that we discussed earlier, I'll use it again. Control abstraction. We discussed this already using functions. So function name, we will see the function name, we can use the function, and the implementation of function, we don't care. So that block of code, uh, actually the use of this function is we can reuse it anywhere, right? We don't have to define again and again. That is one good thing. And control abstraction is the term we can relate it with the function is because we can call the function, but we don't care about the implementation of the function. And for data abstraction, we already discussed abstract data types where we will have some kind of stack or queue, and there will be some functions associated with it, and we can do only those functions on these data types.
Yeah, ma'am.
And yeah, even if we change the implementation of stack from list to some other data structure, still we don't care. We just need to use the push and pop function. That's it.
Okay.
Yeah.
Ma'am, but the new data structure that we will be using, it should support that push and pop, no?
Please repeat.
The new data structure, as you said, that we can change the implementation. So the new data structure that we will be incorporating, or the new features that we will be incorporating, it should support the push and pop first, as you said, right?
Yeah, of course. Actually, when we say that we are changing something, it
Mm-hmm.
shouldn't affect the overall functionality. We should be able to do
Okay.
push and pop, but we don't care how it is done.
And also, ma'am, means though we are defining, right? Even in, like you said, that we don't care about the implementation. We have to define that particular what are the properties and how those properties will work. Then why we say that we are abstracting? Because ultimately we have to define that, no? Once.
So yeah. So one thing I can say is, suppose you are developing linked list, okay?
Hmm.
You are writing the code for linked list,
Hmm.
and I am using that. Okay, I am creating a linked list from your code, and if you are changing some code for adding or removing elements, but as long as it is not affecting my code, whatever I am doing, and I don't care about what exactly you are trying to change, then it is abstraction, right?
Okay, understood. So it is abstraction in a sense that other can directly see and apply rather
Use
than
it.
working on
Yes,
the details.
yes.
But they can modify it from there also, right? They can, if they know how to implement, then
Yeah.
they can modify from there also. That would be a very good means like benefit of using this object oriented programming.
Yeah. So when we come to collections in Java, like in week 6, you will see these kind of things. So we have
Okay.
tree map and all, so tree set, etc. So where we can have elements in sorted order, and we can also, that is the original implementation in ascending order. Consider, and if you want to change that to some other order, you can still do that. You have the permission to do that.
Okay.
So yeah, that is it. Okay, but mainly abstraction, we consider that we don't care about the implementation, but we are able to use it. Shall I go to next topic? Next
Yes,
page.
ma'am.
Okay. Inheritance. So inheritance, I think we have discussed in Python as well. I think you might have already gone through that. It's a very simple concept. Basically, it is reuse of implementations. So as we have not entered into the coding part, I'm not using any code, but all these topics will be discussed in detail. Okay. Now, yeah. Consider we have a company and we have employees there. Okay. And consider we have a class employee, and that stores basic personal data like date of joining, age, name. Okay, just name, age, and date of joining. Now, that is a class employee, and we can create employee objects and store these values. Okay, for each employees. And in the same company, there will be managers. And this manager objects, we need some more functionality. We need extra fields for manager because we want to see the seniority in current role, date of promotion. These data also has to be stored for manager objects. At the same time, manager itself is an employee in the company, right? So manager will also have the same personal data, date of joining, age, name, etc. So we can say manager is some small special kind of employee in the same company, which has, or sorry, who has more details like date of promotion, seniority, etc. So in this case, what we can do is we can have class employee, and instead of creating class manager separately with all these personal data, date of joining, these things, we can use whatever that is there in class employee, and we can add the extra details that we want. That will be supported using inheritance. Getting it?
Yes, ma'am.
Yeah. So again, here it is talking about subtyping. So subtyping is one another feature. So we can say subtyping is basically relationship of interfaces. So suppose we have for subtyping, I'll explain this part. Subtyping is kind of specialization of type. So suppose we have type B on the top, and if we can say A is a subtype of B whenever we can use the object of type A when B is needed. Basically, like suppose we have, okay, let me, okay, where I should write, or take this. B is on the top, okay? Sorry, A is a subtype of B. I'm so sorry.
Ma'am, are you writing something on the?
Yeah, I think I'll write it here. Yes, by okay. So A is subtype of B. So which means A is specialized form of B. In case of employee manager itself, we can say this is employee and this is manager. Manager is specialization of employee. That is clear, right?
Yeah, ma'am.
A, we can actually use B.
Yes.
Did I say the opposite?
No, ma'am.
No, ma'am.
Yeah. So it's like as A is having all the properties of B, whenever we need B, we can use A because A is specialized form of B. So this is called as subtyping. And which is subtype here? A is the subtype of B. Getting it? And if
Yeah.
yeah. So if B has a function f and A will also have function f, right? As A
Yes.
is subtype of B. So we can call the function f on either A or B. That is fine. But we can also change the function definition for f in A. That's also fine. And in Java, what happens is the subtyping and inheritance are, even though they are different concepts, this comes together most of the time. In the case of employee manager inheritance class itself, we will see that manager is exactly the subclass of employee class, and also it becomes subtype of employee class. But that is one case. This is
Mm.
easy case. At the
Ma'am,
same,
so,
yeah.
so sorry, ma'am, to interrupt. So, what is the difference between this inheritance and subtype?
It's not like a difference. How can I, one second, we have a slide that shows the difference, I guess. So what we can say is, take this particular example of DQ. So double-ended queue. So double-ended queue has actually it's like a queue, but it supports operation in friend, insert, insert rare, and delete rare operation. 4 different operations. You can insert and delete from both ends. That is double-ended queue. And we can implement a stack or queue using double-ended queue because stack support only 2 functions, insert friend and delete friend, and queue support only the other 2 functions, not the other 2, insert rare and delete friend. So basically using DQ we can implement either stack or queue, and at the same time we can say that stack and queue inherit from DQ because here we are reusing the implementation of whatever that is given by DQ.
Yeah.
But the special case here is this stack and queue cannot be set as subtype of DQ. Just like in employee manager case, here we can't say stack and queue are subtype of DQ because stack and queue are not supporting all the operations supported by DQ, right?
Yeah, yeah.
Here it is opposite. Here we can say DQ is subtype of stack and queue. So that comes,
Okay.
yeah. So even though subtyping and inheritance comes together, there is difference like this.
Okay, got it, ma'am.
Yeah.
So suppose there is some child class which is taking the attributes from the parent class and also have some other attributes beside that. I mean, all the attribute from parent class and some extra attributes of itself. So in this case, we will say that the parent class is subtype of the child class, right?
No. You said a child class has extra attribute,
Yeah.
then it is subtype.
So parent class is subtype.
No. Child class is subtype. Because child class has more features than parent, right?
Yeah, child has more features than parent, and it also includes all the features of parent.
Then child class is subtype. But
Okay.
in this case, this is opposite. Here, stack and queue inherit from dequeue, but stack and queue doesn't have all the properties of dequeue. That's why it is not subtype. Parent becomes a subtype.
Yeah. So here DQ is subtype of stack and queue because it uses all the all the
Operation, yeah.
operations that are performed by stack and queue are used in DQ. So
Mm.
that's why that is the subtype, right?
Yes.
Okay.
Now, yeah, I think 3 topics are done. Subtyping, inheritance, and abstraction. Is that fine?
Yeah, ma'am.
Yes, ma'am.
Then let's move to the next one as well, dynamic lookup. So dynamic lookup, we can, yeah, you might have seen method overriding, right? Have you remember, like, are you remembering that?
Yeah, ma'am.
Yeah, same topic. So method overriding. So dynamic lookup is in the sense where we have a class, parent class, and a child class. And if the child class, and suppose the parent class has a method f, and the child class also has a method f, and the definition or the implementation of the method f in child class is different from the parent class, but it's like same method but different implementation. Okay, and according to the object created, which method to call is decided. That is called as dynamic lookup. Why? Because the objects are created at runtime. So according to the object at runtime, which method implementation should be taken is decided. So that's why it is called as dynamic lookup. We'll discuss this in detail with code. Are you getting what I said?
Ma'am, can you repeat,
Can you
please?
explain again? Using an example, it would be helpful.
Yeah, right. So suppose we have A, class A, and class A has some function f, and suppose we have class B, and class B is inheriting from class A, okay, and class B again gives a definition for x. This is method overriding, which means we are giving a new definition for the method f that we got from class A. Okay.
Their implementation are different, right?
Implementation is different.
Means how we do a particular thing. We are doing the same, we are getting the same output, but we are doing it in two different ways. Say one is dynamic and one is static way.
No. Suppose here f is printing I'm from class B.
Huh?
Here it is printing I'm from class A.
Okay.
So the implementation is different.
Yes.
Now, there are different ways by which we can create objects in Java. One thing is common, normal. Suppose we have to create a variable object obj1. Okay, the syntax that we follow is class name, object name, use new keyword, and then class name. Okay, now we have created obj1 of type A. And okay, I'll show one more thing. We have stack and heap, right? Stack memory
Yes.
and heap memory. And in stack, what happens is during compilation, we will have this obj1 reference
Okay.
variable. This is our
Okay.
reference variable. And in heap, oh god, this is not going. Okay, I'll write it here. And in heap, during runtime, the new using the new keyword, an object of class A will be created in heap memory. Object A.
Okay.
Object A. Okay. Now,
And can you repeat that part? What is created in stack and what is created in heap?
yeah, stack will have only the reference variables, the variables, not the object itself. The object will be created in the heap memory. It's like we have stack memory here, we have heap memory here, and in stack we'll have obj1 variable, and when the object is created, it will point to the object in the heap memory.
Okay, got it, ma'am.
Yeah. So it's a kind of pointer. We don't call it as pointer, it's a reference variable.
Okay.
Yeah, got it.
Okay.
Okay. Now, when this is done, the object is created at runtime. Okay.
Stack also means in stack also it is created on runtime.
Yeah, but just for this explanation of method overriding, okay.
Uh-huh.
See, this object is created at runtime, and what happens is, let's come to dynamic lookup. Now, obj1, this is a normal case, okay. Here anyway, if you call obj1.f, what will be printed out?
I am from
I
class
am
A.
from class A.
Yeah. Okay. Now consider one more case where we have a obj2 reference variable of type A and object I am creating is of type B. Okay, this is allowed in Java. We can use parent class reference variable to create child class object.
Okay.
Okay, again, now in heap memory we will have object A or B.
B object.
Yeah, we will have object B. Now what will happen when you call function f using obj2? So obj2.f will give us
From
I am
class B.
from class
I am
B.
from class B.
Yeah. And how we actually passed from compiler test? So see here, this line a obj2 equal to new b. During compilation, what happens is we have only this reference variable. Obj2 is of type A, right?
Huh.
So during compilation, it will check whether obj2.f. So is there any
Exist or not?
function? Yeah. Is there any function f that exists in A or not? Yes, it exists. So it passes
exists.
this test. So that's how we escape the compiler test. Yeah. And during runtime, but the object is of type B, and now when you call obj2.f, we are actually calling the function from object B.
Okay, so this is just for means like for making sure that yes, this exists.
Yes.
It is like a safety check.
Yeah. Yeah.
Okay.
Ma'am,
And all this
so-
happens in memory
Yes. Yes.
while compiling.
Yes. Yes.
It is not like it is affecting our entire program.
Yeah.
Okay, okay.
So this is called
ma'am.
as dynamic lookup. According to one second, your voice is breaking. I guess Devanshu.
Yeah, ma'am. So I was asking that in this we write reference variable as A, then object one. We created a variable. So how it is different from just variable that we used to create in Python, like x equals new b. If we like, we would do such thing in Python, right? just object 2 equals to new b.
You're asking how to create object in Python for class?
No, ma'am. I'm just asking. Here we are right, like creating reference variable, and always whenever we are creating variable, we are in front of it we are writing the class
Data
of
type.
it, right?
Yes, yes.
But in Python we don't use to do such. So how this thing is different from that?
So in Python, as it is dynamically typed language, we actually use while we just call the constructor directly. So
Yeah.
okay, you can compare these things. The right side, this is the constructor call in Java.
Yes.
Okay. At the same time in Python, here this is the constructor call car of.
Yeah.
We don't have to specify the data type beforehand. Rather, we just have to call it.
Okay.
Then how there it passes the compilation test? It doesn't compile, right? So it
It
has
doesn't
no
compare.
issue with
It is
that.
interpreter. Mhm.
Okay.
Okay, so here because data type of A and B both classes are same, that's why this is passing the dynamic lookup, right?
Data type of A and B are same. They are related, right? B and A are related. So
Yeah.
this is passing the compilation test.
B inherits
Okay.
from A, right?
Yes, yes.
Okay,
Yeah, I
got it.
actually mixed both Python and Java here. Sorry for that. Just for
No
explanation,
problem.
I went both.
Yeah, ma'am, got it. Got it.
Yeah.
And so if there was a class which was totally separate, suppose class C, so for that, if we have to create an object, we would write C object 2 equals new C,
Yes.
then the compile this.
Yeah. So why is it called as dynamic lookup? Because this is something that is looked at runtime. According
Yeah.
to the runtime object, we are deciding which function to call.
Okay,
Yeah, got it.
understood.
Yeah. Okay, then I think, yeah, correct. 8 o'clock. You can
Ma'am,
pause
just
now,
one
guys. Yeah.
question. One question. Since I'm very new to this Java and everything, so what all things I should cover so that I get a good head start? Means I can cover the basics, but in class, in the object-oriented programming, what all things I should cover?
So all the topics
Before
will be covered in the week itself. So I think if you want to, are you comfortable with Java or are you new to
no,
Java?
I'm not at
Completely
all
new, right?
comfortable.
I
I have
think
just started learning that.
okay. It's fine. So you can start practicing some Java syntax as well. That will be good. So the
Okay,
concept will
and
be
Main
you
problem
can
with
just
Java
listen to
is
listen.
a syntax problem only because when you come to Java from Python background,
Hmm.
Java has a very it is very case
It's
sensitive language. So even if you write a letter in capital, it will throw an error. It may throw an error. So
yes, yes.
it will be better for you if you practice some
yeah.
syntax only because the uh, things which are going to be covered course will be week wise, so I think they will cover everything which is important, but as to give a good start to it, you should start practicing the syntax, especially the data types, because
Mhm.
they are they actually cause a lot of trouble when you go ahead.
Okay, so means master data types and means I was just asking for should I start with classes, working with classes?
No, no, no,
Yes,
no,
Uh,
no. Don't
yes,
start
you
with
no.
can.
classes right now. Start with better to start with just by just write small snippet of code, like just how to print, how to run the main function, just like that only. If you are familiar with that concepts, you will slowly get the right path of how to write the functions of classes and objects, because it's a very deep concept. It just looks like that you will get an idea, but as you grow, it will go a bit deep. So
Hello,
Okay, okay,
hello.
Yeah, Purnendu, by week 2 you will be fine. Week 2 completely gives an head start to Java.
okay.
Yeah.
Hello, ma'am.
Yes, 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 Samir.
Uh, is there any TA sessions or only instructor sessions?
No, no, there are TA sessions on Thursday and
Where in
Sunday.
the calendar?
It's
Yeah,
in the
I cannot.
calendar. Can you please check again?
It's only showing live session Java, but I cannot find, at least in 2 weeks, I did not find TA session.
Anyone else? Can you
TA
please check?
session Thursday it is showing from 6 to 8.
Sunday and Thursday.
Sunday
Uh,
and Thursday.
Yeah,
Just maybe try to
Thursday.
download the calendar again because it's coming from me. I'm being able to see
yes.
it.
I don't know, it's not showing.
Just update the calendar once.
Just try to like remove it and add it again and just check once.
Okay.
So, shall
Hello,
I?
ma'am.
Yeah, let's
Ma'am,
start.
you were saying some compiler for Java. You told for offline it is Eclipse, and for online, what can we use?
Online, now there are no very good compilers, but still, for quick purpose, you can use this Programmers or online GDB.
And secondly, in this course, any tip from you, like how to uh, go about this course?
Please repeat.
Any tip from you how to go about this course?
Yeah, so
Like,
what I felt like very good approach is first go through lectures and also try coding along with that. Okay, and come to live session as well. Don't skip live sessions. If you cannot attend live session, just watch the recordings and also you utilize the TA session as much as you can and practice yourself. Just
Hello.
listening to sessions won't work anyway, no?
and
Okay.
ma'am, in TA sessions, what will be covered? Means our doubts, or and they will be solving
Yeah, what's
GS.
the difference, man, between TA
It
and live
will
session?
be according to you guys only. So mostly you'll like TA will go according to what doubts you have, and we'll also have some contents planned earlier.
Okay, ma'am.
Yeah.
And
Ma'am,
what's the
coding
difference?
is coming in the OPP sessions.
Sorry.
The coding part is coming in the OPP sessions.
Both OPP session as well as Saturday session.
Okay.
Yeah.
Is this enough for the course, or do we really have to watch the recorded the
You have to
lectures?
watch the recordings. Yeah, you have to watch the recordings at least once. Go through the lectures. That will be good.
Hello.
Yes,
Okay.
Sami. Yeah.
Yeah, yeah. What's the difference between TA sessions and live sessions? So we
So
can
live
attend one.
session difference is the live sessions are conducted by instructors, and this will be streamed on YouTube. And TA sessions are conducted by TAs, and those will have recordings. We'll do the recording and put it in a folder.
TA means seniors, right?
TA means they were students who has already completed the course earlier and passed the interview, and yeah, they have very good CGPA, so they got into this.
Okay, and I re-added it. I still can't find TA sessions.
Um, I'm not sure why is that. Let me.
It will be visible on your calendar, Google Calendar.
Can you try adding again? I'll copy paste the link. Rest everyone can see, right?
Yes, ma'am.
Yes,
Yes.
ma'am.
Yeah, ma'am.
Okay. So this is the link for TA session. You can take this Thursday 6 to 8 and Sunday 6 to 8. Yeah. Just note it down if you are not able to find the session in the calendar. Okay.
Are
Uh,
there any graded programming assignments for week one, just like we had in
No,
Python?
not in week 1. You will get it from week 2.
Okay.
Okay. Then thank you everyone. So
Thank
let's wind up this.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, the class is over, right?
Yes, it's over.